When enterprise teams rely on cloud-based AI models, they expose their most sensitive research. Proprietary data is in continuous transit to external servers. To secure this data, we have to pull the entire workflow back inside a strict local trust boundary. We have to guarantee data sovereignty by processing everything on local hardware. We are going to architect a production-grade local AI workspace from the ground up, layer by layer. We begin with a completely air-gapped machine. There are 0 external API calls and 0 cloud dependencies. Achieving absolute data sovereignty is an engineering challenge. We can build cloud-level performance entirely on local infrastructure. Our first architectural layer is data ingestion. For heavy structural document parsing, we use Llama Index rather than LangChain. It retains the structural integrity of the text. To handle massive datasets, we implement 2-stage hierarchical retrieval. By reading only 4-bit int8 embeddings first, we have access latency, filtering the raw data into a highly concentrated candidate set. Traditional databases split text into arbitrary 512 token chunks. That arbitrary splitting destroys the structural metadata required for corpus-level reasoning. Basic bi-encoder retrieval also creates a soft noise problem. It returns data that is semantically similar to the query, but contextually irrelevant to the specific task. We solve this by adding a cross-encoder at a dedicated /re-ranked endpoint. This acts as a secondary, highly precise contextual filter before the data ever reaches the language model. By structuring our retrieval hierarchically and applying a cross-encoder, we drop hallucination rates by up to 40%. Next, we add the senses. To interact with this research via voice without network latency, we need local speech-to-text. This Qdrant chart plots the Whisper model variance based on VRAM consumption and real-time processing speed. For batch transcription where precision is paramount, we deploy Whisper Large v3. For real-time, interactive voice sessions, Whisper v3 Turbo gives us the necessary speed. Now we build the brain of the architecture. A traditional single-turn chat interface limits deep research because it forces the user to manually prompt every step. We replace that chat interface with LangGraph. This lets us build stateful, node-and-edge agentic workflows. The system maintains a persistent state, allowing the agent to draft, verify citations, and correct itself. We connect this graph to the local environment using the Model Context Protocol, giving the agent tools to search files or execute commands. Local multimodal inputs and stateful logic transition the system into an autonomous reasoning engine. For technical research, the agent must write, test, and run computational code directly on the machine. Executing AI-generated code directly on the host operating system is a severe vulnerability. It opens the door to command injection and unauthorized file system access. To prevent this, we isolate the code execution environment from the host machine using a sandbox. Client-side WebAssembly environments start up almost instantly. These are optimal for lightweight, secure data visualizations. This comparative matrix breaks down Pyodide and E2B Firecracker by their isolation mechanisms and latency. While WASM is fast, server-side micro-VMs like E2B take roughly 150 milliseconds to start, providing the robust isolation necessary for complex, Python-heavy operations. Strict micro-virtualization grants the AI functional agency while preserving the absolute integrity of the local machine. The final layer manages UI synchronization. Standard browser databases fail under the load of multi-tab applications. We run a high-performance SQLite database inside the Electron main process. Data crosses an inter-process communication bridge to the renderer process. Here, RxDB absorbs the data to manage the complex reactive UI state without blocking the interface. Enterprise research requires collaboration. Multiple team members edit simultaneously over a local network without relying on a centralized cloud. We integrate YJS and CRDTs. These algorithms seamlessly merge real-time edits and resolve multi-user conflicts locally. Managing state through IPC and CRDTs ensures a real-time collaborative experience that remains strictly offline first. We now have a completely assembled technology stack. It ranges from raw document ingestion at the base to a collaborative user interface at the top. This master block diagram features all of our built layers. Raw data enters the Qdrant vector store. It is orchestrated by LangGraph, analyzed safely inside an E2B Magware virtual machine, and rendered to the user via RxDB and YJS. This infrastructure removes the threat of a third-party data breach, an event which averages over $4 million in costs per incident. By eliminating external data transit and network latency, we satisfy the strictest compliance standards through system design alone. Enterprise AI research requires speed and absolute data sovereignty. A decentralized, deeply grounded, and entirely local intelligence engine delivers both.